Okay, so we start question 1. Write down the full, okay, full and condensed ground state electron configuration of the following atoms. Okay, of the following atoms. Okay, so A-level chemistry, okay, when you're writing the electron configuration, there's no, there was that one that we were writing at grade 12, okay, that electron configuration. But here we don't use that anymore, okay? We have to use the electron configuration based on the orbitals, okay? So you have to know what orbitals are. You have to know what subshells are, okay, for you to find this electron configuration. Okay, so before we solve, let me just give you a quick overview. Okay, so let me say subshells here, subshells and the orbitals. Okay, so an orbital is just a space where an electron can sit. Okay, so these subshells represent the number of not necessarily the number. Okay, so I'm supposed to write shells here because I want you to differentiate this. Okay, shells, subshells, and orbitals. Okay, so I remember when you're in grade 12, you are drawing something like this. Okay, you have a nucleus there, then you have these shells around, eh? Okay, so we said in the nucleus we have protons and neutrons. Okay, then these were shells, and these shells we are finding those electrons, right? Okay, I'm sure you remember this. We're finding those electrons there in these shells. Okay, so this big thing here surrounding the nucleus, they are what we call as shells. Okay, then from shells we go to subshells. Okay, so subshells we have is it 4 of them? Okay, yeah, so we have 1, we have 2, we have 3, we have 4. Okay, we can even go up to 5 or 6 depending on the question. Okay, but most of the questions there, I think they just end on 1, 2, 3, 4. Okay, so these subshells, they can be 1, 2, 3, 4. Okay, and then these orbitals, okay, these orbitals, they can be S, okay, S orbital, they can be P, okay, they can be D, and they can be F, okay. But at A level, you mostly focus on S, P, and D. Okay, so you have to combine, okay, you have to combine shells, subshells, and orbitals to show your electron configuration, okay? You have to combine there. So if, for example, the orbital that you're talking about is S, and it is found in the first subshell, okay? These numbers here, the 1, 2, 3, 4, they are representing subshells, okay? So if you have an orbital that is in the first subshell, okay? And that orbital is S, you write that orbital as 1s, okay? If you have an orbital, okay, that is in the second subshell, but it's also S, you write as 2s, okay? So just like that, you can also have 2p, okay? You can have 3p there, okay? You can have 3d, okay? So that's how you represent the electrons configuration using these numbers here. The 2 represent the subshell, and then the p or the d or the s represent the orbitals, okay? So how do you arrange them? So we have got a systematic way of how to arrange them, okay? So I'll say I have the s orbital here, and then I have the p orbital, I have the d, then I have the f there, okay? So here I'll say that I have my 1s, okay? I have my 1s there, and then what else do I have? Okay, just a minute. Okay. Orbitals. Okay, so what I was saying was that, okay, maybe you have I was saying you have a systematic way. Okay, so these orbitals are supposed to be that side. Don't know everything down there. Okay, so I was saying we have S, we have P, we have D, and then we have F there. Okay, then this side, what are we going to have? We're going to have numbers. Okay, we have 1, we have 2, we have 3, we can even go up to 4. Okay, so these 4 we say they are representing subshells, And then these guys here, they're representing orbitals, okay? So if I have an orbital there, what will it be called? It will just be 1s, okay? If I have an orbital there, what will it be called? It will be 2s, okay? So for this 1s, you can only have 1s. You can never have 1p or 1d or 1f, okay? Then for the p, I mean for the p, okay? For the p, you go up to 2p there, okay? There's no 3p. Oh, I mean, not 3p. There's no 2D. Okay, I meant to say 2D here. Okay. Then here, what are you going to have? You're going to have 3S, 3P, okay, and then 3D. Okay. Again, here you can see that there's no 3F here. And then on the 4, you can have 4S, you can have 4P, you can have 4D, you can also have 4F there. Okay, let me reduce this picture. Okay, so you can see that it increases as you go like that. Okay, so for the S, we only have 1S. Okay, there will never be a 2P. I mean, there will never be a 2S, 2D, or 2F. Okay, for the P, you never have a 2D, you never have a 2F. Okay, so they just go like that. That's the pattern. Okay. So when
So why is it like that?
why is it like that? That's the rule. That's the rule. I also don't know. That's found it like that. Okay, so that's the rule. Okay, so in simple terms, remember here I'm saying this is my first subshell, okay? So in your first subshell, you can never find a p orbital or a d orbital or an f orbital. You can only find an s orbital, okay? Then in the second subshell, you can find a p and an s. In the third, you can find spd. In the fourth, you can find spdf, okay? So that's the rule. You have to follow it like that. So now when you're writing the electron configuration, okay, when you're writing the electron configuration, it means, okay, you follow this pattern. How are you going to get your orbitals? You follow this pattern here, okay? From there, you go like that. Okay, there I've made a mistake. You don't go like that. Okay. Let me change the color here. Okay, so the first one, you go like that, okay? The second one, you go like that. The third one, you go like that. The fourth one, you go like that, okay? This will be the fifth one, sixth one, seventh one. Okay, so meaning when you get your electron configuration from there, you're first going to get 1s, okay? So from 1s there, where are we going? We're going to 2s, okay? So 2s, then from 2s, we are going back to where the arrow is starting there, okay? Where the arrow is starting there and going like that. So meaning from 2s, you're going to have 2p, then after 2p, you're going back to s, okay? Then from this, we'll go there where the arrow starts, okay? Meaning there, we're going to have what? 3p, and then you go back to 4s. Okay, then from 4s here, it means you go back to there, you're going to have 3d, and then 4p. Okay, just like that. It means you are going now to write 4d, 4f, just like that. So this is the general way of representing your electron configuration. Okay, the only difference that is depending on the element that you have been given, the only difference will be the number of electrons that will be there. Okay, so if in the first shell there you have 2 electrons, you indicate that you have 2 electrons. Okay, in the second orbital, you have 2, you indicate that 2. Okay, in the third one, you have 3, you indicate that 3, just like that. Okay, so another important thing before you solve the question that I have to mention is that, okay, is that the s orbital can only, okay, can only accommodate a maximum of what? A maximum of 2 electrons, okay? So whenever we have s2 there, this orbital is full. And then the p can accommodate how many? Can accommodate up to 6, okay? Up to 6 electrons, okay? So whenever you have P6 there, that's the maximum. You can never have P7 there. And then the D1 accommodates up to 10, okay? 10 electrons, meaning D10 there is the maximum. You can never have D11 there, okay? Then the F, but the F is not important. You don't even get examined. Contains 14, okay? 14 electrons. So F, when you see 14 there, it's the maximum, but for the F, it's rare. It's just the SPD, okay? So now that I've given you an overview here, we can simply find the electron configuration of whatever we are given there. Okay, so here you can see that write down the full and the condensed noble ground configurations. Okay, so here we have SI, okay? SI is what? SI is silicon, okay? SI is silicon. So how are you going to find or represent the electron configuration of that silicon? Okay, so you represent the electron configuration of that silicon by simply first you count the number of electrons, okay, that this silicon has, okay, and that number of electrons that silicon has, you just distribute them in those orbitals that we had. Okay, you just distribute them in those orbitals that we had. Okay, so silicon, you go to the periodic table, you check for silicon. Okay, this is silicon here. I'm sure you can see my point. So you can see that the atomic number of silicon is 14, meaning it has 14 electrons. Okay, meaning it has 14 electrons. So meaning, how are we going to show the electron configuration? Okay, so 14 electrons for this silicon guy. Okay, so how are we going to show the electron configuration for this? Okay, so 14, it means I have 1s there. I put 2 electrons. Okay, I'm remaining with 12. 2s there, I put 2 again. Okay, then from this 2s, I go to 2p. Okay, we said how many electrons can go into p? We said 6. Okay, so you can see 2, 2, 10. Okay, it's meaning I'm remaining with 4. Okay, so after 2p, we said what orbital follows. Okay, so you can, if you can remember here, after 2p there, you go back to your 3s, then you go back to your 3p. Okay, so meaning here, I'm going to have 3s. 3s will just have 2. Okay, then that's when I'll go to my 3p there. Okay, so the 3p there, how many would it have? It won't have 2. Okay, so if you count the electrons there, 2 plus 2, 4 plus this 10 plus this 12 plus this 14. Okay, so this is the representation of the electron configuration of silicon. I don't know if anyone has a question. How are we finding that answer? Are we together?
So
yes.
when writing the electric configuration, we always have to follow that one that you gave us when showing us how it's done, that
yes.
order.
This order here. Yes, you have to follow this order. Okay, the one that I showed you so that you get confused when I try it. So, okay, so this one here is the full. Okay, this one here is the full electron configuration. Okay, this one is the full electron configuration, but we've been told we have to find the full one and the noble gas one. Okay, so how do you find the noble gas one? It just simply means that, okay, in your electron configuration, okay, you are going to put a noble gas somewhere. Okay, so you are going to find, where's my periodic table? You're going to count, okay, you are going to get a noble gas before this silicon. Okay, so a noble gas before silicon is what? So you go back like that, okay, then go to the upper period there. Okay, so you can see that the noble gas that comes before that silicon, okay, because we are moving like that, then we come down to here and we're moving like that. Okay, so the noble gas before this silicon is just neon. Okay, and neon has how many electrons? It has 10 there. Okay, meaning those first 10 electrons, we are just going to represent them as neon. Okay, let me put it different. Okay, so this here, these first 10 electrons here, you can see these are 10 electrons. So these 10 electrons, that's the electron configuration for neon. Okay, neon is a noble gas. So that part here, you're going to represent it with neon. You're going to write Ne, okay, meaning that is our neon. Then write whatever you have outside there. Okay, so this is the full one, and this is the noble gas one. Okay, so let's find for another one. What do we have there? We have, this is not a tutorial sheet. Okay, there we have chromium. Okay, and I love chromium because chromium, as well as copper, they have an exception somewhere. Okay, but how to find them is the same.
I have a question.
Yes, yes.
So what's written in the bracket is not really necessary?
Okay, where did I write? Okay, this one here, it's necessary. This one?
No, on the question where it wrote SI, then it wrote used as a semiconductor.
Oh, this one, yeah, it's, it's not necessary here. They are just telling you what this silicon is used for. But when finding the ground state configuration, the full configuration, this one has no use here. They're just telling you where it's used.
Okay, thank you.
So here on B, I'm saying we have chromium, okay? And I'm saying I love chromium because it is an exception to one of those rules that we have. So chromium, how many electrons does it have? Okay, so you go on your periodic table, you search for chromium. Chromium. Here you can see that it has 24 electrons, okay? So our chromium there has 24 electrons. So how are we going to distribute these 24 electrons? Okay, so chromium equals 2. Okay, so 1s, you put your 2. 2s there, you put your 2. And then 2p, you put your 6. Okay, meaning we have 10 there. So we are remaining with 14. Okay, we are remaining with 14. Then what was next? The next is 3s there. 3s, you put 2. Okay, 3p, what are we going to put in 3p? You're going to put 6 again. Okay, so 10 there, and then with this is just 18, meaning we still have like 6 electrons to put. Okay, so after 3p, where do we go? Okay, so remember here my general configuration. Okay, so after 3p, we go to 4s and then 3d. Okay, 4s, then 3d. So that's what we are going to write there. Okay, so 4s, how many electrons that will it have? Hello, I'm asking you guys.
2.
2. Okay, then we go to 3d. How many electrons will this 3d have? The ones that are remaining. Okay, because here it's 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 6, 18 plus this 2 here, you're going to get 20. Okay, meaning how many are remaining? You're just remaining with 4. Okay, so you can see here that we've written the full electron configuration of for chromium. Okay, but for chromium, there's an exception at the far end there. Okay, and they like bringing this as an exam question because they know that students don't really pay attention to the exception. Okay, so what is the exception here? The exception here is that, okay, the exception here is that here in the 4s orbit, okay, you are not going to have 2 electrons. Okay, you are only going to have 1, and then that other one is going to be in the 3d electrons. Okay, the reason why I don't know. I don't know the reason, but that's what chemistry says. They says according to experiments on chromium, okay, the electron configuration was found that in the 4s you don't have 2, you have 1, and then in the 3d you have 5. Okay, so this exception is only seen in chromium or copper. Okay, so whenever you see copper or chromium, just know that at the far end there, you are going to have an exception. Okay, so meaning your electron configuration will be like this for chromium. Okay, you're going to have 2, 2 there, then 2p, 6, 3s2, okay, 3p, 6, okay. Then in that 4s, we know we're supposed to put 2. But for chromium, we don't put 2. That's an exception. We put 1, okay. Then in that 3d there, we're supposed to put 4, but we get that 1 that is coming from here, and then we put 5. Okay, so here this one is the full electron configuration for what? For chromium, okay, the full electron configuration for chromium. And then we have to change it into a noble gas configuration, okay. So meaning we have to get a noble gas that is before this chromium, okay. So if I go to my periodic table there, what is the noble gas before this chromium? Okay, if I go back like that, and then I go up, you can see that the noble gas there is just argon. Okay, how many electrons does argon have? It has 18. Okay, so meaning the part there that has 18 is just going to become argon. Okay, so 10 here, 6, okay, 18. So this part here is going to be argon. Okay, so you're just going to write it as this is the argon. Okay, I don't know why I've written Ag there. Ag is silver, argon is Ar. So R there, and then outside you are going to have 4s1, okay, and then 3d5, okay. So this is the electron configuration. Okay, so for the copper, it's a similar thing, okay. So if you are writing for copper, the electron configuration will be like this.
Sir,
Okay.
I've got a question.
Yes, yes.
So when you've got like that one for copper and this one, chromium, when you're taught to find the electric configuration for the noble gas, you don't add this side, you just add the exception on this side.
What do you mean? I didn't get your question.
The way you haven't put for argon, the way you haven't put this one for 1s2, instead you're going to put that one for 4s1 that side. That's what you do even for copper. You add
This
the
one,
exceptions. Huh?
and at the
Yes.
far end,
Yes, you're supposed to put the way you haven't followed the way it had. You're supposed to follow the ones at the end and not the ones this side.
yeah, you're just supposed to follow the ones at the end. These two, the last 2 orbitals.
But why, when it has 18 electrons, why aren't you adding the first part?
Which first part are you talking about?
This one, sir, since argon has 18 electrons, why aren't you adding 1s2, 2s2? Why aren't you adding that?
Okay, so argon has 18 electrons, right? Okay, so these are the 18
Yes.
electrons here I put in the box. And your question is why am I not adding what?
Here on the answer, why have you put 4s1 and 3d5 instead?
Okay, this is what is remaining here. You can see on top here.
Yes.
On top here, okay, okay, let me go back to the 4-1. So we said the 4-1 is this. This is the 4-1, eh? Okay, the full electron configuration.
Yes.
Then They're saying
Yes.
write it in the noble gas configuration. So the noble gas configuration, it means we have to get the nearest
noble gas.
It's the nearest noble gas. And the nearest noble gas here is argon, which has 18 electrons. Okay. So how do you count those 18 electrons? We said we add 2 plus 2, which is 4, plus 6 there, which is what? 10, plus 2, which is 12,
18.
plus 6 there, which is 18. Okay. So this is the
18.
Yeah, this is the 18 here in the box. Then whatever is outside there remains the way it is.
Yes.
Yes, that's what we did there. So this argon here is represented by whatever is in the box. Then the rest they are outside. So we wrote them just the way they are.
So, sir, you're supposed to equate it to the one on top, not the way you wrote it like this here, huh?
I'm supposed to equate it to the one on. I'm not getting your question. I don't know how. Why?
I'm saying the way you've written AR, then you put it in brackets, and then you put this other one in brackets, the 4S1. That you just put it to show that, yes.
Okay, you don't put this in brackets. I think I was just explaining. You put it like this.
Then my question was, why you put it next to the argon instead of you writing the 1S2, 2S2? That was my question. Because you underline to show like that's the answer. That was my question.
Okay.
Now you've understood it?
Have I answered your question first? I have not.
Okay, it's fine, sir.
Okay, I don't know why I'm not understanding your question. I don't know. Okay, so this is for argon. Okay, even if we had copper there, even for copper it would be okay. So the noble gas before the copper is still argon. Okay, so the first 18 electrons of this 29 here, they are going to be represented by the argon. Okay, so 18 minus 29 minus 18, what is going to remain? Okay, 29 minus 18, what is going to remain? You're going to remain with 11 electrons. Okay, and then those 11 electrons, you are going to represent them like this. Okay, so the argon represents the first 18 electrons, right? Then we have how many electrons remaining? We have 11 electrons. Okay, so those 11 electrons, they must be put in 4s and 3d. Okay, so in the normal sense, we're supposed to put 2 here, okay, and then you put 9 there. We've cut for the 11 electrons, okay? But since it's copper and chromium have an exception. Here on the 4s, you only put 1, okay, and then the 1 will go to the 9 like that. So meaning that there we have 1, and then on the other side you have 10 there. Okay, here you have 1, and then on the other side you have 10. So this will be the electron configuration of copper. Okay, so I don't know if you've understood. Okay, so meaning this one now you can find, this you can find, for silver you can find. Okay, it's very much easier. Then even this one you can find, okay? So here you're just simply finding the electron configuration for an ion, okay? So we know that for an ion, either it gains or it loses electrons, okay? So if it's positive, it means it has lost. If it is negative, it means it has gained. Okay, so let me solve one here. Okay, let me solve one there, I'll show you. So I've gotten AOB plus, okay? Mean RB plus. So RB plus, what is RB plus? Okay, so when you go on your periodic table there, RB there is just the rubidium, okay? RB is just rubidium. And rubidium has how many electrons? It has 37 there, okay? So we have to arrange the 37 electrons, okay? So you first have to write the electron configuration for just the normal rubidium, okay? Okay, so I'll use the noble gas configuration. I'll use the noble gas configuration because it's easy. So what is the noble gas before this rubidium? Okay, so before this rubidium, if I go back like that, then I go on top. You can see that the noble gas before rubidium is krypton. Okay, and krypton has how many electrons? Okay, krypton has 36 electrons. Okay, and then rubidium has 37. Meaning, I'm just going to write that here I have my Kr. Okay, krypton is what? Is it Kr? Okay, krypton is Kr, meaning they have my Kr there, okay, representing how many electrons, guys? 36, okay? So how many electrons now are remaining from those 36? Okay, we're just remaining with, one electron, okay? So how are we going to represent that? Okay. right, electron configuration for rubidium. Okay, so meaning here this one has 36. Okay, then if you listed it, you end up where you have 5s. Okay, and that 5s will just have a 1 electron. Okay, so 36 plus this one is equals to the 37. Oh, why am I writing 35? The 37 electrons that this rubidium has to have. Okay, and then for your LB plus there, it means this rubidium is losing 1 electron. Okay, means this rubidium is losing 1 electron there. Okay, so it's losing 1 electron there. It means you only remain with the configuration of this krypton, because this 1 electron here will be lost. Okay, because this is a plus. Okay, so meaning the electron configuration there will just have the one for krypton. Okay, and you can write for krypton 2 there, 2s2. Okay, then you have 2p6, then we have 3s there, 2, 3p there, 3p6. Okay, then we have 4s2, then we have 3d, which is 10. Okay, okay, so how many electrons do we have here? 10 there. When you end here, you have 10, there you have 18. Okay, supposed to have 36. Okay, here you have 12, meaning we are remaining with how many? Okay, so after 3d, which orbital are we going to go to? Okay, so after 3d, I'm pretty sure I have to go to 5s. Okay, no, not 5s. We have to go to, okay, let me check. You can get confused. Okay, so according to this rule here, after 3d, you go to 4p. Okay, then after 4p there, you go to 4d. Okay, then after 4d, you go to 4f. Okay, but I think we're not reaching there. We're not reaching that side there. Okay, so let's include 5 here, because again, we saw a 5 in there. Okay, so if we have 5 there, it means here, we're going to have what? We're going to have 5s. They are going to have 5p. They are going to have 5d. They are going to have 5f. Okay, and they are going to have 5g. Okay, so meaning what configuration are we going to have? Okay, so after 4s there, okay, after 4s there, means you have to go to 3d. Okay, after 3d, you have to go to 4p. Okay, after 4p, you have to go back to 5s. Okay, then after 5s, you go to 4d, you go to 5p, just like that. Okay, so meaning there we ended on 3d, we are going to go to 4p, then 5s, then 4d again, then 5p, just like that. Okay, I don't know if we've done the correct thing there. Okay, I don't know if we've done the correct. Okay, so where was that? Okay, it was here. So there we are 3d to the power 10. Okay, then we said we go to 4p, and in 4p we are going to put what? We are going to put 6. And then in 5s, how many are we going to put? We're going to put just 1, that is remaining. Okay, so let's count here to see if we have those numbers. Okay, so let's count. So you have 2 plus 2, 4 plus 6, 10. Okay, so 10 plus this 10 here, we have 20. Okay, then I have this 2 plus this 2 plus this 2, I have 30 there. Okay, I have 30, then plus 6 plus this is 37. Okay, so this is for the normal rubidium like that. Okay, then for the rubidium plus, okay, it means this 5s1 here is going to disappear. Meaning, what are we going to remain with? We're just going to remain with 1s2, 2s2, then 2p, 6, 3s2, okay, then 3p6, and then what else? 4s2 there, okay, then 3d10, then we're going to have 4p6. Okay, so we're going to end there for the ion. Okay, so that's how we find for the ion. Then let me quickly move to question 6. Okay, let me move quickly to question 6 because Twitter John has to come in with physics at 21. Okay, so in an experiment, red light, okay, with a wavelength of 700 nanometers falls on a metal plate in a vacuum tube to which a voltage has been applied. Okay, at this wavelength, no electrons are expelled from the plate. Okay, but when yellow light, which has a wavelength of this, okay, is used, then the electrons are expelled from the plate and the current is detected. Okay, but no electrons are expelled at a wavelength only slightly higher than this 580. Okay, so the question there is now, what experiment? Okay, what is this experiment called, and what does it prove about the nature of light? Okay, so this experiment where you have, let me draw here. Okay, so this is the experiment where I have a metal there. Okay, then I have on this metal, I shine a certain type of light, okay, with different color. On this metal, when this light strikes this metal, okay, if this light here has a threshold frequency that can make these electrons to move. These electrons will move from this metal, they will move away like that. Okay, so this effect where you're shining light on a metal to make electrons move, okay, it is called the photoelectric effect. Okay, so this experiment, answering question 1 here, what is this experiment called? It is called the photoelectric experiment. Okay, photoelectric experiment. And what does it prove, okay, about the nature of light? Okay, so the photoelectric experiment simply proves that, okay, the photoelectric experiment simply proves that light does not only exist as a wave, okay, that light does not only exist as a wave, but also as particles, okay, and those particles are called photons, okay, photons like that. Okay, so it proves that light does not only exist as a wave, but it also exists as particles, which are called photons. Okay, so I hope I've answered that. And then in this photoelectric effect, okay, the threshold frequency of magnesium metal is this. Okay, calculate the wavelength in nanometers of light with this frequency. Okay, so what formula are you going to use there? You're just simply going to use this formula. Okay, so the speed of light is just simply equals to the wavelength multiplied by the frequency. Okay, so the frequency we have, this light, this speed of light we have, and we want to find what? We want to find the wavelength. So wavelength there is equals to the speed of light over the frequency. Okay, so the speed of light is a constant value, okay, which is just 3.0 times 10 to the power 8, okay, over, then what is it? Our frequency. Okay, so our frequency there that we've been given is 6.55 times 10 to the power 14. Okay, so 6.55 multiplied by 10 to the power 14 like that. Okay, so let's divide there and find our answer.
So in this video, I'm going to show you how you can register for our lessons. Okay, so what you need to do is open your browser. It can be Google Chrome, Samsung browser, or any other browser that you are using. And then you type in DISCRETE learning, okay, DISCRETElearning.com. Right, so once you type in, you click enter or search, and then it will load and it will take you to this login page. So if you have an account, just go straight in and log in, okay? If you do not, you need to create an account. So I'll click create an account, okay? So create an account, and then this here will pop up. So you put your names there. So I am Paul Solutions, and then here you put in your email, okay? And then here you put the password that you want. So I'll put 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can put any password that you want there. Here you're going to type your phone number. Okay, and then here you put your date of birth. So I was born on 6th February 2025. Okay, so you can put any date of birth there. And then here you are going to select your university. Okay, so we have a lot of university here. You can see there's Unza, CBU, Mulungushi, Cavendish, all these universities. Okay, so you click the university that you belong to. Okay, so for example, I'm going to click University of Lusaka. Okay, and then you click register. Okay, so it's going to load and it's going to tell you that you have successfully created your account. So what you need to do now is put in the details that you registered with. So you put in your email here that you used, and then there you're going to put in the password that you set, and then you click login. All right, so once you log in here, it will take you to this dashboard. Okay, so this dashboard here, Okay, let's remove this. So this dashboard here has all the courses that we offer. So there's chemistry, math, physics, biology. Okay, if you're taking linear algebra, you can register, introduction to real analysis, all that. Okay, so let's say, for example, you want to register for mathematics. So what are you going to do? Okay, you're going to click open. Okay, so you can see they're saying you're not enrolled in this course. So what you need to do is click subscribe. Okay, and then it will bring all the courses that we offer. So you tick the one that you want. So maybe I want to register for mathematics, okay, and chemistry. And then on the right here, you choose the duration. Okay, so I'm going to say math 1 month, even the chemistry 1 month. Okay, let me even put physics and biology here. So I'm registering for those 4 courses. So once you click, once you select the courses, you're going to click enroll. Okay, you wait for it to load. It will take you to this page that will show you the total amount that you're going to pay, okay, for all those courses that you've selected. Okay, and then you click pay. All right, so you're going to have this drop down that is going to come. Okay, so here you put the phone number that you're going to use to pay. Okay, you put the phone number that you're going to use to pay. If you are paying using maybe a mobile money agent, okay, tell them to put their number here. Okay, and then you click pay now. Okay, so it's going to load. So you wait for it, and then it's going to take you to this page. Okay, so here it's telling you you're about to pay DISCRETE Learning Institute the sum of whatever there. Okay, so what are you going to do here? You are going to click pay. So once you click that pay, okay, this page here is going to pop up. Okay, so once this page pops up on your phone or your PC, okay, you are going to receive a pop-up message on your phone telling you to import the password for your mobile money. Okay, so once you import the password for your mobile money, you will be able to be letting into the website. Okay, it means you have registered. Okay, so let's say, for example, let me put in my password on my phone now. Okay. Okay, so when you come back to the dashboard, you are going to see that now you are enrolled in math, chemistry, physics, and biology there. Okay, so allow me to explain some of the things that you can see here. So on this menu here, if you click that menu, the menu will disappear. If you click it again, it will appear. So on the menu there, we have this where it's written learn. Okay, so when you click on learn, you're going to find all the courses that you are registered in. Okay, and then you can close that. You can click YouTube channels. You're going to find our YouTube channels there. Okay, so you can click maybe Tutor Solutions. Okay, you're going to go to my channel here, and then you can watch some of the videos. Okay, to ask you to subscribe, so you subscribe. So it will show you some of the videos that I've uploaded on my YouTube channel. Okay, but on the website we have a lot of them. So I'm going to show you how you can access all that. So let's go back here. All right, so on my YouTube channel, you mostly find math and chemistry, and then for Tutor John, okay, for Tutor John, you're going to find biology and physics, and then for math with Marius, of course, you're just going to find math. Okay, so I can close that, and then I open this one for study materials. So when I click on study materials there, it's going to take me to this page where we have different study materials based on your university. So if you're from Apex, you open the Apex folder. If you're from Unilas, you open the Unilas folder. Then you open that just like that. If you're from UNZA, you open the one for what? For UNZA. All right, so let's go back there and then check what we have inside the courses there. So we have talked about all these here, okay, on the menu. So if, for example, you want to learn something, okay, you just open, okay, this course, and then you're going to, if you open math, you're going to find general mathematics and probability and statistics for second semester Apex. So this one here is specifically for those who are doing second semester Apex. Okay, for the rest of you, you just go in the general mathematics. Okay, so you're going to find 4 folders there. One will be for the lessons and tutorials. The other one will be for the handwritten notes. The other one will be for the tutorial sheet and assignments. The other one will be for what? Past quiz, tests, and exam papers. Okay, so the setup is the same. Even if you go in the chemistry folder, the biology folder, the physics folder, any folder that you go into, you're going to find the same. So if you go in lessons and tutorials here, okay, you're going to find all the topics that you can have in math. So you can see there are a lot of topics, right? So let's say, for example, I want to learn maybe SADs and rationalization. So I'll click SADs and rationalization there, and then I'm going to find 3 folders. Okay, so the first one is for the notes. The second one is for the recorded tutorials that we record for ourselves. And then here where I put supplementary tutorials, okay, there are other videos that you can use to learn. So if I click on slides and notes here, you see you are going to find the notes here. So you can click any to study them. Okay, let's click this one here. All right, so the notes are going to open like that. Okay, so they have opened there, so you can go there and you can study them. Okay, so these are your notes to study, so make sure you study them. They are very simple and simplified. Okay, so what if I leave these notes? Okay, I also have these notes here that I wrote by myself. So you can go through these notes to learn. Okay, so if you don't want to read the notes, you want the videos, you go in the recorded tutorials. Okay, so you click there, you're going to find the videos here. So there's intro to SADS, whatever I can see there. Okay, so let's play the introduction to SADS. So you click on it, it's going to open like that if you're using a PC, so you can move a bit up like that, and then you play it. Okay, so you can start learning here. Okay, you can start learning. You can see the video is playing. If you want to fast forward, you just click on these two things here that are on the screen. So you can double click on them. You'll be fast forwarding your video. And then at the end here, okay, at the end here, I have these two icons here. Okay, so the last one there puts you in full screen mode. So if I click it like that, my video is going to appear in full screen mode like that. Okay, so you can watch your video in full screen mode like that. Okay, if you don't want the screen mode, the full screen mode, you can still watch. That's the way it is there. Okay, so we also have this icon here. So this icon is for picture play. Okay, so you can play your video while doing something else on your PC. So if you click on it, you see I'm going to have this a small thing popping up there. So even this is on your phone. So you can be playing your video there, and then you can even leave this browser. Okay, so you can even go somewhere else. Okay, like this. So you see it's still there. Okay, so you can play it, and then to return to full screen mode, you just click on it, and then you'll be able to return to the full screen mode here. All right, so that's it on the lessons and tutorials. The setup is the same in all these topics that you can see. So just pick the topic that you want to learn, and then you'll be able to learn. All right, so after that, you can check out the handwritten notes. Okay, so these handwritten notes, most of them have a password. Okay, so the password is PB4511. Okay, so you can open the ones for set, you'll find them. Okay, you study them just like that. So these are very good notes. They are very simplified. So make sure you use them. All right, so those are the handwritten notes. And then when I go to the tutorial sheet and assignments here, I'm going to find different universities. Okay, so if you're from Apex, you go in the Apex, you open, you're going to find video and written solutions. So the video solutions, you open there, you're going to find, depending on your intake. So this was for the January 2024 intake. This was for the 2024 July. And then for your intake, which is 25 this year, you place there. Okay, so you see the videos that we've solved so far there. Okay, so you can open them if you want to learn. So it will come, you can play it, and you'll be able to learn there. Okay, and then what else? Okay, you can also check out the written solutions here. You're going to find some of the written solutions that we upload there. All right, so if you do not see your university here, you can go in this folder where we wrote our tutorial sheet and explained solutions. Okay, so you open this folder, you're going to find a lot of tutorial sheet based on all the math topics, okay, that you can have. So this tutorial sheet here have solutions. So for example, if you want to learn functions, okay, if you want to learn functions, you just have to open this folder here. Okay, just have to learn open this folder. Okay, let me say I want to open the one for the logs and the exponentials. So you click on it. So it's going to open here. Okay, so you have the questions here. Okay, so you can take note of the questions that you have and then try to solve them. And then once you are done, go below the questions there. You're going to find the solutions. So these are the solutions there. Okay, these are the solutions there. So you can learn using them. Okay, so you can go back there. And then if you are taking a stats and probability, we have some tutorial sheet here. So you can open and then you can check them out. Okay, we also have more worksheets on the probability and statistics. You can check them out there. All right, so we are done with the tutorial sheet folder. Okay, so you just go to your university there. And then when you go to the past quiz, test, and exam papers, you're going to find a similar setup, okay, to the tutorial sheet folder. So if you're from Apex, you go to Apex. If you're from Unilas, you go to Unilas. If you're from Mukuba, you go to Mukuba. So for example, if I go to Mukuba here, I'm going to find video solutions, okay? You can see the video solutions for some revision of their test papers. And then even you can even go in the written solutions there. You're also going to find the written solutions. Okay, and then here we have some past papers on probability and statistics. All right, so that's how you can use this drive. Okay, so feel free to try out whatever you want. Okay, so search for whatever you want on this drive. You're going to find them. Okay, even in the chemistry there, if you open, it will be a similar setup, general chemistry for the rest of you. Okay, and then if you're doing second semester Apex, you go in this folder here. Okay, so let's try to go in the general chemistry there. You're going to see the setup is the same. Okay, so if I go tutorial sheet maybe, and then I open the folder for UNZA, okay, you're going to see video and written. Let's try to open the written ones. You're going to see the tutorial sheet for the chemistry that they take at UNZA. So you can open any. Okay, you can open that. You find all these tutorial sheets that are solved. Okay, you can open this folder, you find all these tutorial sheets that are solved. So make sure you use what is on the drive. Okay, so our Learning Institute, okay, is the best because you can learn at any time, anywhere. Okay, you don't wait for us to teach you. You can actually teach yourself. Okay, but we also have live classes. So when you register, you have two types of classes that you're going to be attending. Okay, one is the live classes where we interact and you can ask questions. And then the other one are the recorded classes that you find on this website. All right, so that's all about this website. Feel free to register yourself and then start learning, okay? Thank you so much.